In this video, we'll be looking at the oxidation of alkanol. The oxidation of alkanol refers to the reaction of alkanol and oxygen. So, the reaction of alkanol and oxygen is what is referred to as the oxidation of alkanol. And the oxygen is usually supplied by what is called oxidizing agents. And the two main oxidizing agents that are used in oxidation of alkanol are potassium heptazodichromate 6 and potassium tetraoxomanganate 7. So these are the two major oxidizing agents that are used in the oxidation of alkanol. Remember, the oxidizing agents are those substances that will supply oxygen to the reaction. So these are the two main oxidizing agents that are used. So you want to know which product is formed when alkanol reacts with oxygen. Which product is formed? So the product that is formed will depend on the type of alkanol that is used, or it will depend on the type of alkanol that is involved in the reaction. And basically we have three types of alkanol. We have the primary alkanol, the secondary alkanol, and the tertiary alkanol. So this page shows the oxidation of all the alkanols that we have: the primary alkanol, the secondary alkanol, and the tertiary alkanol. So for the primary alkanol, when it is oxidized, remember I said in the previous page that oxidation of alkanol refers to the reaction of alkanol and oxygen, and that the oxygen is supplied by the oxidizing agents, and the two main oxidizing agents that are used are potassium heptazodichromate 6 or potassium tetraoxomanganate 7. So when a primary alkanol reacts with oxygen, remember the oxygen is supplied by either potassium heptazodichromate 6 or potassium tetraoxomanganate 7. So when primary alkanol reacts with oxygen, alkanal is formed, and this alkanal is also called the aldehyde. So this is high yield. You can be asked in an exam that what is the other name for an alkanal? An alkanal is also called an aldehyde. So when a primary alkanol reacts with oxygen, an alkanal is formed, or aldehyde. And if the oxygen is still present in excess, the alkanal that is formed will further react with oxygen to give you carboxylic acid. So the oxidation of alkanol, of a primary alkanol, goes this way. The primary alkanol is oxidized to give alkanal, and then the alkanal is further oxidized to give alkanoic acid, also known as the carboxylic acid. So the end product of the oxidation of primary alkanol is the alkanoic acid, which is also called the carboxylic acid. This is the end product of the oxidation of the primary alkanol. It is high yield and very important. You can be asked in an exam that when primary alkanol is oxidized, which of the following product is formed? So an alkanal is first of all formed, and on further oxidation, an alkanoic acid will be formed. So for the oxidation of secondary alkanol, when a secondary alkanol is oxidized, that is when it reacts with oxygen supplied by these two oxidizing agents, an alkanone is formed, and alkanone are also called the ketones. So an alkanone is also called a ketone. So this is very important. It is quite different from the primary alkanol. Primary alkanol are oxidized to form alkanal or aldehyde, which on further oxidation will give you carboxylic acid, or also known as the alkanoic acid. For the secondary alkanol, when they are oxidized, an alkanone is formed. Then for the tertiary alkanol, when a tertiary alkanol is oxidized, no product is formed. And the reason no product is formed is because tertiary alkanol cannot be oxidized. Here we're looking at the oxidation of the primary alkanol. So when a primary alkanol is oxidized, an alkanal is formed, which is also known as the aldehyde. And on further oxidation, alkanoic acid is formed, also called the carboxylic acid. So this is ethanol, a typical example of a primary alkanol. When it reacts with oxygen, that is when it is oxidized, a substance called ethanol is formed, and this compound is the alkanol, also called the aldehyde. And on further oxidation, this ethanol that is formed will eventually give us the ethanoic acid, which is a carboxylic acid. So the end product of the oxidation of primary alkanol will always result in the production of the alkanoic acid. So if it is ethanol, ethanoic acid will be produced. So this is the structural formula of the ethanol, a typical example of a primary alkanol. So when this ethanol is oxidized, a compound called ethanol is formed. So this is the structure of ethanol, and water is also formed. So the ethanol reacts with oxygen to give ethanol and water, and this ethanol that is formed on further oxidation will now give ethanoic acid. That is when the ethanol reacts further with oxygen, ethanoic acid is formed, and this is the formula for ethanoic acid. So for the oxidation of secondary alkanol, when a secondary alkanol is oxidized, when it reacts with oxygen, which is supplied by either of these two oxidizing agents, an alkanone is formed, and we've already established that the alkanone are also called the ketone. This is a typical example of a secondary alkanol. This is propan-2-ol, and when this compound reacts with oxygen supplied by either of these two oxidizing agents, propanone is formed. Propanol is an alkanone, also known as a ketone. So structurally, this is the structure of propan-2-ol. It's a typical example of a secondary alkanol. So when this compound reacts with oxygen supplied by either of these two oxidizing agents, propanone is formed, and this propanone is known as ketone. So this is all about this oxidation of the secondary alkanol. Then for the tertiary alkanol, tertiary alkanols, they cannot be oxidized, and the reason they cannot be oxidized is because the oxidation of alkanol involves the loss of hydrogen and the gain of oxygen, and the tertiary alkanol have limited hydrogen available for oxidation. So the simple reason why the tertiary alkanol cannot be oxidized is because they have limited hydrogen available for oxidation. This compound is a typical example of a tertiary alkanol, and if you look at this compound, there is no free hydrogen here. We have CH3 here, a methyl group here, and an OH group here. So it will be difficult to oxidize this compound. So this compound cannot be oxidized because of one reason, because there is no free hydrogen available for oxidation. Unlike that of the secondary alkanol, this is a secondary alkanol, and if this compound should undergo oxidation, the oxidation will be geared towards this hydrogen atom. So it is this hydrogen atom that is oxidized to give the propanone. Same with the primary alkanol. So this is ethanol, a typical example of a primary alkanol. When it is oxidized, it is one of the hydrogen here that is oxidized to form ethanol, and on further oxidation, one of the hydrogen as well will be oxidized to form ethanoic acid. So secondary alkanols are oxidized to give alkanones, while tertiary alkanols, they cannot be oxidized because they have limited hydrogen available for oxidation. So in summary, the oxidation of alkanol will depend on the type of alkanol that is involved in the oxidation, or the type of alkanol undergoing the oxidation. So primary alkanols, when they are oxidized, alkanol is formed, and when the alkanol is further oxidized, an alkanoic acid is formed. So this is the end product of the oxidation of the primary alkanol, and this is the intermediate product. So you can be asked in an exam that what is the intermediate product of the oxidation of a primary alkanol. So the intermediate product is the alkanol, and the final product is the alkanoic acid. Then secondary alkanol, they are oxidized to form alkanone, and tertiary alkanol cannot be oxidized, and we've already established the reason for that. And the reason is because they have limited hydrogen which are available for oxidation. So because of the fact that they do not have available hydrogen atom, they cannot be oxidized.